Let's solve a triangle. We want to solve triangle ABC if angle B is 55 degrees 40 minutes, side B is 8.94 meters, and side A is 25.1 meters. Well, based on the information given, it looks like I can solve for angle A to begin with using the law of sines. A over sine angle A is side B over sine angle B. I'll fill in the information I know. 25.1 over sine angle A, which I don't know, equals 8.94 over sine angle B, which is 55 degrees 40 minutes. I want to isolate sine A, so I'm going to multiply by sine A, or maybe I'll cross multiply to get 8.94 sine angle A equals 25.1 sine 55 degrees 40 minutes. I'll isolate sine A by dividing by 8.94 and continuing over here. So sine angle A is 25.1 sine 55 degrees 40 minutes divided by 8.94. At this point, I want to pick up my calculator and calculate this value. If you do so, you'll see that sine A comes out to about 2.318 and so forth. Well, recall the graph of the sine or just the range of the sine function. The sine is never greater than 1. It cannot be 2.318. There is no triangle that satisfies the given information. Let's solve a triangle. We want to solve triangle ABC if angle A is 55.3 degrees, side A is 22.8 feet, and side B is 24.9 feet. The first thing to look for is angle B. We have angle A, and side B. Let's look for angle B using the law of sines. And we can use it in its reciprocal form. The sine of angle A over side A is the sine of angle B over side B. And I'll fill in the information that I know. I know angle A is 55.3 degrees. Side A is 22.8. Angle B is what I'm looking for, and side B is 24.9. I'll multiply by 24.9 and therefore isolate sine B. Sine B is going to be 24.9 times sine 55.3 degrees divided by 22.8. Stop at this point and pick up your calculator and calculate this value. You'll find with your calculator in degree mode that that comes out to 0.89786 and so forth. And it turns out that for this equation right here, there are two solutions. Sine is positive in quadrant 1 and quadrant 2, and angles in quadrant 1 and quadrant 2 are all legitimate sizes for angles in a triangle. So let's start by finding what I'll call B1 by taking the inverse sine of 0.89786. And B1 comes out to 63.9 degrees. There's a second possible solution to this equation, as I just mentioned, which is found by using 63.9 as a reference angle into quadrant 2. And so subtracting it, 63.9 degrees I mean, from 180, and I come up with a second possible angle of 116.1 degrees. I know that the second angle is a legitimate second angle and that there are two triangles that fit this given information, provided that 116.1 plus 55.3 don't add to more than 180. If they did, I would cross off of this as a second possible triangle angle in a triangle. Well, since 116 plus 55 don't add to more than 180, there are two triangles that we need to find to solve. Let's start with B1 equals 63.9 and work with that. Given that angle B and the fact that angle A started out as 55.3 degrees, let's find an angle C by taking 180, subtracting 63.9 degrees, and subtracting 55.3 degrees. This particular angle C comes out to 60.8 degrees. Given that angle, I need to find a corresponding side. I'm going to use the law of sines again. A over sine A equals C, the side I'm looking for. Let me call it C1 because it corresponds to B1, over sine of the angle C that I just found. If you look back at the original information, you'll see that side A was 22.8, angle A is 55.3 degrees, side C1 I'm looking for, angle C that corresponds to side C1 is 60.8 degrees. I'll multiply by sine 60.8 to get C1, side C1, by calculating 22.8 sine 60.8 degrees divided by sine 55.3 degrees. With the help of a calculator, you'll see that side C1 comes out to about 24.2 feet. And we've solved one particular triangle. That's a solution to the original problem. We should solve the other by taking our other value of B. If you look back, what we found for B2, we found that B2 was the angle 116.1 degrees. Again, angle A was 55.3 degrees, and so we want to find the third angle in this particular triangle by taking 180 degrees, subtracting 116.1, subtracting 55.3. This particular angle C comes out to 8.6 degrees. I want to find the side C that corresponds to this, again using law of sines, A over sine A, C over sine C. Side A is 22.8, angle A 55.3 degrees. Side C, let me call it side C2, so it's clear that it's a different side C, divided by sine of 8.6 degrees. I'll multiply by sine 8.6 to get that C2 can be found by taking 22.8 times the sine of 8.6 degrees divided by the sine of 55.3 degrees. With the help of a calculator, you'll find that that comes out to 4.15 feet, which is another possibility for the second triangle that satisfies the given information. Let's solve a triangle. We want to solve triangle ABC. Given angle A is 43.5 degrees, side A is 10.7 inches, and side C 7.2 inches. Well, based on the information that we're given, we should look for angle C first. Let's use the law of sines in its reciprocal form. Sine angle A over side A equals sine angle C over side C. And fill in what we have. We have angle A, 43.5 degrees, side A, 10.7. We're looking for angle C. We know side C is 7.2. Let's isolate sine C by multiplying by 7.2. So we see that we have sine C is 7.2 sine 43.5 degrees divided by 10.7. We're going to stop at this point, grab a calculator, and calculate this value. We end up then with that sine of C is equal to 0.46319 and so forth. It's approximately that, not exactly that. Well, there are two solutions to this statement right here. The sign is positive in quadrant 1 and quadrant 2. Let's find the angle that satisfies that statement in quadrant 1, and I'll call it C1, by finding the inverse sine of that in degree mode on my calculator, and that comes out to 27.6 degrees. A second angle that satisfies this statement is found by using 27.6 as a reference angle into quadrant 2. So finding 180 degrees minus 27.6. If you make that calculation, 180 minus 27.6, you get 152.4 degrees. So it looks like there might be two answers to the question. There might be two triangles that fit this given information. However, if you take 152.4 and add 43.5, you end up with 195.9, and that means that these two cannot both be angles in a triangle. They themselves add up to more than 180. This is not a second possibility. There is only one angle C. We're going to use it to solve the triangle. So let's take that angle C, that 27.6 degrees. We had angle A. Angle A was 43.5 degrees. And let's find the rest of the parts of the triangle, starting with angle B. I'll find it by taking 180 degrees, subtracting 27.6, and subtracting 43.5. If I make this subtraction, I end up with 108.9 degrees for angle B. I still need side B. Going to the law of sines, side B over sine of B is equal to side A over sine of angle A. Side B is what I'm looking for. Angle B I just found to be 108.9 degrees. Side A you can find by looking back at the original information given. It's 10.7. Angle A is 43.5 degrees. To isolate side B, multiply by sine 108.9. Side B can be found by taking 10.7 times sine 108.9 degrees and dividing that by the sine of 43.5 degrees. And with the help of a calculator, in degree mode, we can find that side B is approximately 14.7 and our units are inches. Let's talk about the law of sines. Here's what we want to do. Without using the law of sines, let's explain why angle A equal to 104 degrees, side A equal 26.8 meters, and side B equal 31.3 meters cannot be valid for a triangle ABC. Well, there's two things to note. First of all, angle A is 104 degrees, which is obtuse, bigger than 90 I mean. So the other two angles, both angle B and angle C, must be smaller than angle A. However, side A is smaller than side B, and in any triangle, it has to be the case that the biggest side is opposite the largest angle. If angle A is the largest angle in the triangle, side A would have to be the largest side in the triangle. This cannot be a triangle for that reason.